So today we're going to do precipitation reactions, and I thought it'd be really cool to start with a pretty spectacular one. So what we've got here is lead nitrate. Now, who can tell me about nitrates? What do we know about nitrates?
All nitrates are soluble.
All nitrates are soluble, so that's why this is an aqueous solution. So we have some lead nitrate, and I'm going to pour some of it in here. There's these droppers, but we're not going to worry about that. You can see it looks like water, doesn't it? But it isn't. It's a soluble compound. And lead is a poison, so you really don't want to be putting this down your sink. That's why we have a lead waste beaker after we've finished. And here we have some potassium iodide. Now, potassium iodide is also soluble, and it also looks like water, but it isn't. I'm going to put that in the second beaker. So this one here, in this side, is the lead, and this is potassium iodide. Lead nitrate, potassium iodide. I'm going to write this up on the board. They both look like water. And then I'm going to pour one into the other. So we're going to mix them. Ready? Now that is a precipitation reaction. It looks like paint. Eventually it will settle out and you'll have clear liquid at the top and a thick yellow powder at the bottom, but it will take a while because it's very finely suspended in there. So we'll just leave it in the waste for a while, and I'm going to write on the board that reaction. So we had lead nitrate, lead +2, so you have to write the right formula, aqueous because it was soluble, plus potassium iodide. Potassium is +1, iodine is group 7, so it's -1. That's the right formula, AQ. And we need to work out what the new products might be. So we can see that lead's a cation. It can't go with another cation, so it has to go with the other anion. So it's PBI. And this is +2 and this is -1, so we need a PBI2. And then what we do is we leave the state of it because we're going to check on that, and we're just going to write our other product down, which is potassium nitrate. Now all nitrates are soluble, so straight away we can write aqueous because we know that rule. But as for the other product, we need to consult on our prac, and this is the one we're doing, precipitation reactions. There's a table of rules that will tell us how to predict whether it's going to come out of solution. But we know it did, don't we? We saw it. Here it is. It's starting to separate. You can see a small solid at the bottom. See if you can focus in on that. So it's a more solid at the bottom, and it's starting to come out already and have a clear top. All good? So we don't even have to look it up. We know that this is coming out. We know it can't be this, don't we? It cannot be this, so it has to be this, solid. But we can then confirm it with our rules. So if we take up the table and have a look, it says, where does it say? It doesn't talk about iodides, does it? Most chlorides. So it's in with the iodides are a halogen. By halogen I mean they're in group 7, and they sort of behave very similarly. I'm just going to use your periodic table. So group 7 is this group here, the halogens, They've got this pink colouring because they're very reactive nonmetals, and they behave very much the same. So lead iodide is insoluble like lead chloride is. Can you see how lead chloride is insoluble as well? So they haven't put it on this prac information because it wasn't part of the prac. I just decided I would do a nice spectacular one for you instead of boring white ones. So that's an example of a precipitation reaction. I was going to just talk about one more. So what you're going to do is on this dimple plate, you're going to put various combinations of these compounds here. So you've got sodium hydroxide, silver nitrate. Silver nitrate you have to be careful with because it stains your skin brown and it does not come off until it's worn off. Sodium sulfate, copper sulfate, iron chloride, ferric chloride, sodium carbonate, potassium nitrate and sodium chloride. So you've got these in little dropper bottles like this, and you're going to drop 3 drops of it and then you're going to follow the table. So in your prac, unlike this one here, you've got a blank table and you're going to combine those two and then write what happens. And you're going to fill this whole table out with what happens. Yes, it looks like that, thank you. So when it's expanded out, yeah, that's right. You're going to fill this table out. And, oh, I see, one got left on the other side, which is not ideal, is it? Never mind. So you're going to fill this out. You're going to write whether it forms a precipitate or not. Just have fun with it because being white tile, it's very hard to see white precipitate. So you have to really look for a bit of a haze or something. And if you're unsure, it might be slightly soluble. So if you think it's slightly soluble, write that down. And that's it. I just thought I would just show you one more, just so you're sure. So one of the combinations on here is silver nitrate? Yes, silver nitrate and ferric chloride. So maybe not. No, it isn't, but we can do that one because I know that gives a precipitate. So let's do another example. Silver nitrate, aqueous, ferric chloride, and we're going to react these two together. Following the rules, you know that it's going to be silver chloride plus iron nitrate. What do we know about nitrates? They're all soluble, so we can write aqueous. If this indeed is a precipitation reaction, which I know it is, this is going to be a solid. You can check with your table there. It does say silver chloride is insoluble. Have a look at your table. It will come out, and this is a white precipitate. But I don't think it's one of the ones you need to do. So with that, I'm going to leave you to do it. And what you need to do is put the 3 drops in of each, give it a stir with this toothpick, and then record your results. Once the tile is full, go over to the sink, use the washer bottle to wash it off, pour the tap, and dry it with paper towel. Be careful because you don't want to get the chemicals necessarily on your skin. If you do, they're very dilute, they're 0.1 molar, then you just make sure you wash your hands with soap. So carefully rinse it off. Maybe do this first and then rinse it off, whatever suits, and then dry it and start the process again. Any questions? So once you've done the whole table, there's questions to answer. These questions here, but also for every precipitate that you find, you need to write a balanced chemical equation, and that will be great practice for you. So you need to work out what the precipitate is because you've got a choice of 2, and it won't necessarily be as easy as a nitrate. So you need to check your table. Once you work out what, say you've worked out this one and you don't know which is the precipitate, you go to the table and work it out. And get started. So of course, when you're writing a balanced chemical equation, you not only have to write the right formulas, but you must balance both sides, and then you can work out what your precipitate is. So you can see that this is not a balanced equation. We've got 2 iodines, so we need a 2 there. That gives us 2 potassium, so we need a 2 here, and we have 2 nitrogen, 6 oxygen, so that's right. And down here, we need to balance this one as well because we have 3 nitrogen, so we need to put a 3 here. And now we have 3 silvers, so we need to put a 3 here. We have 3 chlorines also, and we've got 3 here, and now that is balanced as well.